Okay, so similar to page 1, this video will cover just page 2. It's asking you to come up with a triangle that has these three angles, a 30, a 70, and an 80. And then it's asking you, is it possible to come up with just one additional triangle with the same information, the same three angles? And again, we're trying to look for a different triangle. It can be a different shape, it can be a different size, but basically, again, what I mean by different is the two triangles one triangle cannot be placed on top of another triangle to fit perfectly using our rigid transformations. And so different meaning it's just not possible. The bottom problem, we're doing two angles and a side. You'll notice the two angles here are the same, two of the three angles at the top here. And again, I'm asking, is it possible to come up with another triangle, again, different shape, different size. And this time I want all of the possible triangles, where here I'm just asking for one additional triangle. So go ahead and work on that with your partner. And when you're ready to continue, turn the video back. So I'm going to provide a few suggestions. So if you weren't able to come up with an answer, maybe the suggestions will help. So for problem number 5, you're not given any length, so you can just draw any arbitrary length as a starting point. And the idea here is, can you come up with, again, two different triangles with the same information? In the bottom triangle, I would recommend, since you are given a length of 5, that you use length 5, let's say a couple of times, and make sure that, again, are you able to get a different triangle with 5 being the base of both triangles. So if you weren't sure how to get started, this is how I would suggest starting. Just draw some arbitrary length. Here, make sure the lengths are 5, since that's the length that you're supposed to have, and then try to build the triangle from there. So you, hopefully this is enough information to continue the construction if you were stumped. And again, when you're ready to continue, turn the video back on. Alright, so in problem number 5, you're asked to do a 30-degree angle. So I'm going to label the endpoints here A and B. So looking for a 30-degree angle. Off of one side, I'm choosing the 30 and the 70. And then off the other side, I'm going to, or other endpoint, I'm going to do the 70. And then draw in both sides. So this is my 70-degree angle. That's my 30, which makes the 80 at the top an automatic, because the sum of the angles of the triangle, based on our triangle angle sum theorem, is 180. So if I know two of the angles, the third angle is what's ever left of 180. So we want this triangle, again, another triangle that is different in terms of shape or size. Because when we do rigid transformations, the size of the triangle doesn't change, nor does the shape change. So for the bottom, I would again do the 30. I would do the 30 off the left, as these for the first example, and 70 off of the right side. Again, having endpoints drawn will help keep everything as accurate as possible. So this is 30 on this side, 70 on this side, and then the 80, of course, is at the top. I only would recommend putting in the numbers that you're being asked to use. So even though this angle at the top we know is 80, it's not one of the three numbers that we're given. So is it possible to make the triangle different shape, different size? So again, if you are done, continue with the video. If you're not finished, go back and continue working, and then turn the video back on when you're ready to continue. Alright, so problem number 5. If I wanted to make the triangle either different shape or size, the angles I can't change, but what I can do is make sure that I start off with a length that's longer than the original length. So I'll call this line segment CD. So I can still do my 30 and my 70, but this time I'm forcing the triangle to be larger since I'm choosing a longer segment. So 30 on the right side again, 70 on the left side. On the left, 70 on the right, and then 80 at the top. So there's no way that we can do a rigid transformation, take this triangle and make it fit this triangle, because rigid transformations does not change the size of the triangle. So these triangles are considered different even though the shapes look like they're the same. Alright, so for the bottom picture, if I would put the 70 on the left side and the 30 on the right side, would that make the triangle different? So again, 3 numbers, so the idea is kind of come up with different possibilities, leaving the 5 at the bottom. And so if I would put the 70 here and the 30 here, hopefully you can agree that basically all I've done is I flipped the triangle over. In other words, I've done a reflection. So that's not going to make the triangle different. It's going to be the same size, same shape, it's just been flipped over. So sometimes kind of mapping out the ideas can help us. So if I could put a 30 here, for example, and a 70 here, 5 at the bottom, how else could I construct this so that the triangle might be different, keeping the 5 at the bottom? So if you haven't thought about this way, then this might be another way of trying to approach this problem. So again, turn the video off and think about, again, how many possible combinations can we come up with, and then turn the video back on and we'll look at whether there are other triangle combinations or not. Alright, so if I put the 30 on the left side, I'm going to put the 80 in here just for the conversation, that there are 3 angles that we know. And if I put the 70 here at the top and the 80 in the bottom, that would put the 70 in a different place than the original triangle. So here, the 80 degrees is opposite the 5. The second one, the 70 is opposite the 5. Again, is it possible to come up with another triangle where the arrangement would be different? So think about that. Again, turn the video off and work on that. Construct the triangles, and then if you have everything, turn the video back on. So since the 80 is opposite the 5, the 70 is opposite the 5, what isn't opposite the 5 is the 30. So if I put the 70 and the 80 coming off the 5 and make the 30 opposite the 5, then every angle of the 3 angle possibilities are all opposite the 5. And if I change these, replacing the 30 and 80, all I'm basically done is flip the triangle over, so it would be a reflection. So this has 3 combinations. So the question is, if I build these 3 combinations, do I actually end up with different triangles? So if I put 30 off the left and 80 off the right this time, instead of 70, so 30 is here, this is the 80, so again, our numbers are 30, 70, and 5, so I'm going to put the 70 at the top. I'm not going to put the 80 here, even though that's what we used, because again, the numbers that we're trying to, the triangle we're trying to construct has these 3 numbers. So sometimes when constructing something, if I know 2 of the angles, I can use the 3rd angle if needed to construct it, since I know the sum of the 3 angles is always 180. Then for the last one, put in 5. The left side would be a 70, the right side would be an 80. of the segment EF. So off the left side for the 70, look like this. Off the right side for the 80, just like that. So we have the 70 on the left, the 30s at the top. So this, it's clear that definitely the last triangle is different than the first two. But the first two look pretty similar. And so the question becomes, are they the same triangle or are they different? This is where pi table can be helpful. Let's sketch the triangles. This is 30 here and this is the 70. I come over here and make sure that I line up the 30 with the 30 and the 70 with the 70 by flipping the triangle over. You'll notice that the two triangles are not the same. So this one here has three different triangles based on the fact that we can arrange the angles in a different order. So going back to number 6, is it possible to construct a different sized triangle? The answer is yes. Actually, if you look at your partner's triangles, I'm going to guess that your partner's triangles are probably different than yours based on however long this segment was to begin with. So yes, and there are a lot of possibilities. And then for the problem 8, how many are there for problem 8? And there are 3 possibilities. So yes, it's possible to get other triangles, and there are 3 possibilities. So before we end this video, the question you may be asking is, so why are we doing this activity? So so one of the things we talked about in our last class is that we can use transformation as a way of proving two triangles are the same by either translation, reflection, and or rotation. And we can accept transformations as a way of proving that two triangles really are the same. Also on, that was what we did last night. Also on Monday, we looked at flowcharts for the first time. And flowcharts and using definitions, theorems, and algebra properties is another way we can validate that this rule is actually true. So usually, quite often for proof, we're trying to prove something, some characteristic to be true for a shape, or some algebra rule actually works for some shape or pair of shapes. Another way of doing proof is through construction. And so, for example, going back to that first problem that we did, if I said to you, construct an equal out triangle where the length is 6 centimeters, hopefully we can agree that there would only be one triangle. Just like problem 1 with a length of 4, there was only one triangle that's a 4 by 4, 4, 4. And that's true for any length I choose. We should all get the same triangle. That in itself is a proof, in the sense that we know that there's only one possibility. In problem 5 up here, if I give you 3 angles, the answer is it's not enough information. There's no way to prove that we're going to end up with the same triangle. Same thing is true for problem 7 at this point. If I give you 2 angles on the side, and I ask you to construct it, it's possible we could get 3 different answers. And in mathematics, we don't like that. And so that's not enough information to be able to say we're all going to get the same answer. So part of the construction here was trying to figure out under what situations will I get just one triangle, and what other situations are there more than one possible answer, and then therefore what other information do we need to be able to guarantee that if we all do the same construction, we will all end up with the same triangle. So how do we use construction to develop one possible answer? We're going to go on to the last page. So this will be in the next video. So go ahead and get started, and then when you're ready to continue, turn the last video on and start checking your answers.